Of course, also harmonization of this is a big problem already as one part. But one of the things I wanted to show you there is that the distributed storage, the highest value is at the low duration, whereas bulk is at the high duration. So as you probably sort of imagined, depending also on the application, the perception that the energy storage that is built for the automotive work in the same quality for the energy storage for grid is not correct, because the depth of discharge and the charge cycle is completely different. And a lot of this is coming from materials, quality of the materials that are serving the required depth of discharge and that. So the way we started this task was starting from a survey to see the infrastructure sort of owners, what do they focus on, and what is their interest in view of the energy storage as well as the applications they have in mind. So we did a survey of the technologies and application across all the infrastructure to identify which technologies are of highest interest. So we focus on that. Obviously, we're not able to focus on all 15 different sort of energy storage technologies to find these relationships. We need some focus, and also on the application side, we wanted to make sure we are as focused as possible. So as I said, the application is important because of those attributes at the application side, discharge duration and response time. So result of that was basically mainly sort of lithium ion as we expected, and also more on the hydrogen storage, and then response on the interest for the grid application was the highest, with the peak shaving and load leveling as part of the survey. The view of the deliverables, I'm just going through some titles and I go through some details of it. So one deliverables was on the validation and the data sets for different technology domains. The idea of this was to look at the spectrum of the different tools and analysis that we have to basically relate the descriptors and the materials to the device performance parameters, and that was the main content of the first deliverable. The second one was on the sort of describing of those methods in more details, and also do analysis using those methods, and finally to define the performance metrics across different parameters as well as across different technologies. We also had collaboration with other work packages, especially work package 1, especially task 1.4 on the data side and the metadata side, which you heard a lot of that yesterday and today a little bit, and that was also part of the collaboration. We also had a good collaboration with the tasks within this work package, especially interconnection across sort of device and systems and so on, which I think would be something that would be discussed in the next presentation. In terms of training, we have organized a few of the training sessions to introduce the concept, focus on the data and metadata structure that will help to make these descriptors more understandable at the materials to the device level. We had some webinars as well as some in-person and also online webinars that I think the details of that is in the reports, so I'm not going to go through all of that. So one of the things I want to talk about is mainly on the metadata platform, a bit in more details. So one of the things we use is basically, so as I said, descriptors are not easy to find from a physical sort of point of view. There's no science that really gives you a property of the material would lead to a better sort of energy storage device. This is a very data-driven work. So you need a lot of data to basically understand how some attributes at the materials level would lead into a better device at the device level, which leads to a better system operation. The way we did this was, our idea in the project was not to develop huge sort of database of materials, was to develop a framework so that we can rely on that as a sustainable framework, so that we can use it down the road for increasing of the database as well as sort of utilization of the database in the process that we're looking for. So this framework that we have developed is based on converting all the tabular data or the unstructured data into a framework that we call it the graph database. In a nutshell, what it does, it makes the retrieving of a database across different sort of infrastructure and entities much easier. So I explained that a little bit yesterday, that if you have battery testing data from infrastructure 1 and you have battery testing from infrastructure 2, the way this type of data is annotated is different in each lab. They call voltage, performance, all mixed up into their sort of jargon and their own terminology. So what this system does, essentially collect all that data first, and there is a training process that basically it understands each of these type of data, how it relates to the actual terminologies, which is governed with something we call ontology, which is a language across all this infrastructure. The ontologist essentially makes the terms and attributes across all these data sources uniform. So once those are sort of injected into the system, there is a process of training. Once that training is going into a large sort of accuracy, typically over 95%, we have the system ready for injection of data. Once the data ingestion is happening now, all the parameters into one table collected into one node. So meaning that if I'm looking for a specific data out of millions of tables, want to compare for a specific data from large table from another entity, I can just compare these two without going through all the big tables. And that's what really the power of this graph databases. So this is our framework that we have developed to basically convert the sort of unstructured data into machine readable graph database and be retrievable from the databases that we have. We have put that into platform that we have developed internally at FSHA for many years. We have put some testing data already there. We have a pipeline to basically ingest and retrieve data. We don't have a lot of massive data there yet. We have data for hydrogen. We have data for sort of battery materials, but the framework essentially is there, and it can be used for collection of the data and for retrieval of the data. In terms of the ontologies, we have tested a few of the ontology studies out there, like BAT-info and also the one that we have developed. And the framework and the pipeline of the data is basically is adjusted to both of these. Pipeline of data means that I start from my query, and the end of the pipeline is what I get as an output. And this pipeline is something you can create into this platform directly. So the other aspects of that is basically metadata schemas, as I mentioned, is also included into that. So if you upload data, it creates a metadata. If you upload metadata, it creates metadata of the metadata as well. If your data does not include metadata, it creates some level of metadata, but obviously we don't expect all the historical data contains so long metadata already, right? So some examples of the schemas and all that is here. So one aspect that we wanted to have in the platform, as I said, was that we wanted the analysis tools that develop and use in the StoRIES also be included into this platform. So the user can use those data and do analysis and apply that into the use case directly. And the data and everything would be collected over time. So that's a way that we can make sure that the number of data and also the enrichment of data is happening sort of over time as part of it. So you will see some example of the analysis tools that we have already done. So this is basically the database of materials from devices that basically value one energy storage technology depending on the chemistry compared to the others. We have so these are some examples of the storage databases, which is categorized on the technology and system level, and the category of the attributes on the operation and the performance. So that's just the structure of that database. So this database, we had it from some other sort of elements from EPRI as well as DNVGL and in the past, and we added what we have collected in the project StoRIES, so it's more extensive. These are some examples of the use cases you can run with this. So if you're looking at the sector of commercial industrial, you're looking at the electricity market, which is not that important in this case. It's just for the sake of the pricing of electricity services, a number of services being bundled. It gives you a ranking of the storage technologies. The difference between this and the other analysis tool is that is properties of the materials is involved into the process of the data ingestion here. So if you have two different chemistry of batteries, the attributes that define this ranking is changing as a result. We're writing something on this recently. So Lazar is working on a publication on this that we're working on describing this in more details. And the last part was the database for the material acceleration platform that we had as one of the deliverables. We have put these databases in terms of some of the entities that are actively using this for the material acceleration platform, which is one of the way that you can sort of screen materials for the energy storage applications. We have recently been working with EU MACE, which is a cost action, European cost action with a specific focus of the materials for the energy application and acceleration, and combined our databases with what they have. So as you can see, we have entities across Europe. They do different type of analysis. They are not focused entirely on the storage. They focus on a lot of different aspects of materials. We're trying to utilize those databases also in terms of the infrastructure beyond what the StoRIES offer in terms of the collaboration sort of opportunities in the future. And that's pretty much it. Thanks. Questions?
No questions?
Yeah.
Take the mic.
Take a mic.
Is this one?
Both of them.
I don't know how to switch on this, but I don't know how to switch on this one. Yeah. Yes. Hello?
Yep.
Fantastic. Can you select from all the database if you give some parameters for the applications that you have or you want to have a battery for and storage technology? Can you choose from the database what's the perfect match?
Yeah, so that's the analysis tools that I mentioned. So one of the analysis tools that we call Smart is already in the platform. You can basically go and, sorry, I'm not trying to presentation. You can basically go there and say, I'm looking for this application. I'm looking at this technology, let's say lithium-ion battery, chemistry, XYZ. That's where sort of material database is coming to play. And you define some other parameters which are not something, it's on a screening sort of level. It's not at the details of type of modeling that, for example, Kai is doing. It's on the screening, like we look at one pricing for the electricity, for example. We don't do it like hourly pricing in this case, just let's say sort of annual price, whatever. And based on that is rank all the technologies. So it can tell you a chemistry A of the lithium-ion battery is good for this application versus 2 and so on. If you want to go deep into purely new type of materials that is used and not tested into the sort of application yet, it's more difficult because those descriptors are not defined well and you have to do a lot of experiment to make it available. I think Project StoRIES was not about doing purely sort of material science data, was more describing this relationship across sort of materials that are already in production and the storage technologies and the application for energy storage.
And have you got any interest from the industry? So how was that interest?
Industry, I would say from hydrogen, we got some interest. They were, especially the electrolysis, they were interested for example, the non-PFAS type of materials, how the impact of that would be to the hydrogen production, which relate to power to gas sort of capability of the new technology. That was one of this. In the past, we had some interest into this as well through some other entities, but what we did really in the StoRIES was to improve the sort of materials database part of it. Previously, it was more purely on the technology and device level to the system. We added a lot of sort of materials to it, and we hope we get more interest as well to industry as well.
I can imagine.
Yeah.
Thank you.
Thanks.
Next to the hi. Yes, with task 3.2.
This was really the presentation.
Well, thank you for and thank you also for preparing the ground so well for this next. Before I go introducing myself, I want to acknowledge that there's a lot of people that are not named here that have made this accessible, because this work has been a very collaborative work. Some people who are here in the room, my colleague Sarah is in the back. I see just Papa has been also collaborating with me from CMAT. There were collaborators from SINTEF in Norway and from ANEA, who are not in the room, but maybe following online. Gabriela and Rafael, shout out to you. So this work has been based on the understanding that, in a way, it was prepared now by Gorosh. Gorosh has emphasized that, well, in order to know where the value is for the storage, we need to understand those applications. And what we have looked into is, well, if you want to model these applications for hybrid energy storage, how should you talk about them? So there's the emphasis on building a framework, similar to what Gorosh was emphasizing, for understanding energy storage systems, to the system and the application level. We're building up the levels, but we keep the same idea of, well, it's about maturing storage and finding where it's useful. My name is Kai Heusen. I'm a senior researcher at ETU, and I've been leading this task. We can start with, is this a pointer? It won't work, right?
You have
no.
this one, if you need.
You get the high-tech one.
Oh.
Sorry to the people online, I'm bringing a big stick here. Well, what I want to emphasize is, so this task has emphasized two objectives here. So one is to have a framework for guiding this cross-level hybrid energy storage system model, both for the development and integration, and then to also define, I would say, some benchmark or the benchmarking process for such systems. In order to understand this, we first have to define what is hybrid energy storage. You've seen different definitions about this. The way we look at it is to distinguish also at what levels are we looking at the hybridization. So you could say, well, if energy storage uses a material inside a device in a system on an application. The application could be an energy community, but it could also be grid scale storage. We saw several examples yesterday. So we are focusing on what's on the right. Be close to the microphone here. So we could combine storage in this hardware or software levels in an application. So you could have completely off the stack, off the shelf subsystems that you're just integrating in an application, and you are interested in this in the form of hybridization. So those are the types of things we wanted to harmonize and understand better. To do this, we looked at it in 3 levels. We first developed a modeling framework, thinking about what are performance indicators that would be relevant to assess, and how would they actually be formulated at these different levels, the device level, the system, and also the application level. We developed a pipeline for simulation and evaluation, and then we applied that pipeline, that concept, to concrete cases where we implemented models and we tied them together, and to have some showcases, and those are then available in the open source. So you see, that makes these 2 different things about my talk relevant. What are the guidelines about KPIs, the framework, and then a few cases. To understand the challenge a bit better, I want to show you, by example, these different levels where these different KPIs come in, because they're all like intuitive when you hear them. So of course you care about the system cost in terms of capex and opex. You would also care about efficiency, round trip efficiency and lifetime, or you would care about the CO2 performance of an application. Well, you can't really assess the CO2 performance of a battery if you don't account for it where it's used. It will have its own material-based production process, CO2 emissions, but it will also have application results where the abatement comes in. Right? So those things have to be traded off, and they're traded off at the application level. So what we would like to be able to assess is the whole thing. And let's say the engineers, mostly engineers involved in this task, are used to making more these application level models. And we wanted to align this with the information that we get maybe from a life cycle assessment on the material. So we had some ideas about this. And one of those ideas is that there is a relationship, how these indicators influence each other. So if you change the application, you will change the operating pattern. So that ranking that you get in the spider web diagram might actually change. So there's an interaction. And that's what we wanted to capture with our framework. That if you change the system, you change the requirements, you will change the operating pattern, and you will change some of the KPIs that you calculate. So there's some dynamic aspect of it. And maybe it's in the margins, maybe it's going to be impactful, but we wouldn't know before we have properly investigated that. So is this any relevant? We asked. And for that matter, we had in 2023, we had a workshop at one of the events organized by KIT or at KIT at that point, where we invited in StoRIES and we had a panel discussion to really bounce up that idea at a few different stakeholders, and we learned something there. For example, that those things that we care for as researchers are not always the same priorities that the industry has, and that kind of trade-off was interesting to observe, and it helped us focusing on which benchmarks, on which approaches we should take. So, for example, we identified that the value is very context dependent, and this notion of the application and system level discussion that only emerged more strictly afterwards, once we found out that it was difficult to distinguish those things. The state of the art in the area is also that there is no framework that is aligned yet, so there is an open gap. And we did hear actually from the industry that there was a lack of tools and benchmarks that they could use to actually assess the state of the art applications. So in short, the industry likes the batteries because they know what their interfaces are, they can deploy them in a box on their applications. The engineering effort behind it is where we are actually contributing in some sense with our models by providing several possibilities of benchmarking storage applications. So there was a gap that is still to be filled more properly, but we've identified it, and that's what we're working towards. So now the framework, just shortly, as a concept, the idea is that we have a framework.
Yes, sure you will.
That works. There you go.
I know this now.
Oh, yeah.
This is even visible online. So on this side, we have the user input. We want to be able to modify the configuration. We want to have the modules that are used in a yeah.
Now it's gone.
Want to have the user input to be on one end, and the rest of the pipeline should be automated, so that we can actually work with these platforms that Roche was presenting and deploy such solutions into an agentic way. Everything is configurable in the beginning, and we integrate all that complex simulation framework. We have the scenarios that things are evaluated, the input configuration in some tables, diagrams. We have a complex simulation of multiple models that are coordinated, and we get the KPIs at the end. So that was the idea of the framework, and just to make it on the example that we saw before from Rush, we can deploy it in similar to a simple hybrid energy storage, where you see here in the diagram that it's composed of three technologies: flow battery, lithium battery, a supercapacitor, and the controller. Also importantly, and those things influence each other. And what you can do in this platform is you can select which technologies you'll evaluate, and then you get different performance indicators that have been specified for these applications as the output. So that's a simple application of this framework. It's a simulation model that runs rather quickly and is integrated and rather simple. If we want to make it a bit more realistic on other applications, when you go into hybrid energy storage and you have thermal applications, electrical storage, and they are connected, you have to think a little more about what is the relationships here. So we use the same idea. So we have the system configuration, module configuration, scenario data. We have to describe what the application is properly in the documentation. So we have a documentation that defines what is the benchmark about. And that defines then what are the different types of KPIs. We use this dynamic and static notion to say what comes from the simulation model, what comes from other databases. And then we care more only about the ones in the dynamic KPI in our specific task. But we want things to be aligned so that they become coherent in the end. So this case, get it a bit more concrete. We developed what we called for a long time the reference case. It's applied to something you could call a renewable energy community because it involves different types of loads, so buildings, maybe process industry, different consumers. It has CSP as an input and also solar and wind as an input. And then we have electrical storage and also thermal storage in it. Some of the efficiencies or flexibility gains that you can have is from storing cheaply bulk heat versus the more expensive electrical storage. And those we wanted to then see in the end how this ranks in our KPIs. You can find the outcome, it's open source. You can, if you find the QR code, you find the model in a specific configuration, it should be directly deployable on your machine. It involves optimization and MATLAB Simulink models. So there was quite some integration work. I don't have time to go into the details also of the KPIs now. But what we provide here is, as an overview, we have So we see here in this area, the way we made our user interface using an Excel diagram with some color codes, where you can provide the configuration data that you can modify. We have two different locations. So this is the port. No, this is the StoRIES location in Spain. We have also the location in Italy, Portici, where we make all the data configurable to one place or another place to model the idea of a workflow where you can deploy this case in different locations. In principle, geographically, but you would need different inputs, and you can translate all the data from one place to another. And on the output side, here we have different types of KPIs. So we have several economic KPIs that are listed here: CO2 emissions, reduction as an environmental KPI, and then here 6 technical KPIs that are being quantified automatically in the framework. And here benchmark for 6 different case studies that you can find in our book chapter. The results, and you also find them. You try out the case that we published. So, but just to summarize the outcomes that we have, I'm stacking them here on top. We had the stakeholder workshop, which the results are also included in the deliverable 3.4. So the deliverable was submitted this summer, which provides the framework, guidelines, and a summary of all the case studies that have been integrated. One of the case studies has been published as a book chapter in StoRIES book, and as mentioned, we published the open source books. So that's the outcomes we have from our task, and thank you for your attention.
Are there any questions?
Yes.
Thank you for the presentation. I was just wondering, how far down do you go on the device level simulation? Because those can get very complex and very computationally intensive. So where do you stop?
Yeah, that's a good question and an infinite one to answer. It's more about the computation. Once you have the framework in place, you can use the detailed model. It would just be slower computation. So we made a trade-off. We use these MATLAB simulating model that are calibrated in the lab. So let's say the level of detail we have used is, and that's why we have two different models. We have an optimization model that is abstracted, and then this MATLAB simulating model that tries to represent the technology. And some of the technologies are kind of like Excel sheet level of detail for the thermal technologies, and then for the electrical ones, we have dynamical models that correspond with calibrated to the millisecond or second level responses with lab data from CML. So it's more the framework, but yeah, it is possible, and then there's no possibility to define that level of detail in strict sense. But you can basically, if you take our MATLAB model and you have a better battery model, you could take that out and the simulating model and replace it. And you have to do the fine data engineering to make sure that it's true in the end. But yeah, we're a good way there. Thanks.
Any more questions from guys? Then thank you very much. Then we go for 3.3. Do the people online hear me if I use this phone?
Yes, yes.
Yes.
I think so.
I feel
So you like to move first.
Yes. Task 3.3. Here again, my colleague Roberto did a fantastic job coordinating the task, which had two of the main deliverables of the project: roadmap and the strategic research and innovation agenda, the SRIA. This work package here, this task here, 3.8, has been very connected across the project to other work packages, and specifically with the work package 1, with working groups 1 and 4, were external reviewers for these two main deliverables. What is the background for task 3.3? We have so many experts here on material science, system level, and of course energy storage. I would like to take some seconds and think what's going to be the technology, the storage technology that's going to be key and that's going to be present in almost every energy system in the coming 10 years. As for fast, resilient, energy efficient, you have it. Well, if you're wrong.
No, we didn't.
Because precisely the point of StoRIES is that there's no single solution. And you are not wrong because choosing the wrong technology. The question is wrong. We get this question constantly from industrial actors, from politicians, and from funding organizations. What's the technology, the storage technology that we have to fund to develop to solve the problems of the future? There's not only one. We have to think that system, and we have to think on how to connect different storage technologies. And this is what work package, what this task focuses on. And before continuing explain the super colorful, a nice picture, I'd like to take a tale from this book called Bible to explain what this task is about. Does everybody know the story of the Ark of Noah? Yeah, well, Noah was one day walking by the desert, thousands of years ago, and then God told him, Noah, things get very ugly, you have to make a boat. It's going to be a bee coming, and you have to get ready, bring a couple of each animal, and then get prepared for when things get ugly. Then it happened. Well, what we are doing in the task 3.3 is playing bubble with it and telling society and specifically the energy community that things are going to get out. Energy systems are becoming more dependent on renewables, which are becoming more and more intermittent and difficult to integrate in a smooth way. Every system is becoming more and more complex. And we are seeing the first whole country blackouts in history. So within all this, we have to raise our voice and say, we need to think different. We have to think on having systems that combine different parts of the energy picture, from electricity to those that are more focused on carrying fuel, heat, and all the different components of these areas. And within this, we have decided to think on the system level within two different areas. In front of the meter, from the energy production, we're having also grid applications and off-grid and energy islands. And then what's behind the meter from a more end-user perspective, where we have selected two main sub-areas being smart solutions for mobility and smart buildings. So within all this, we have to provide the message on that we have to think on energy storage as being a key component interconnecting not only one, but at least two or more of these parts of this picture here. So that's the main point of very much StoRIES, but specifically for this for package 3, task 3, sorry, which is that there's no silver bullet solution. Hybridization is essential. So for this, we have to first identify those parts where, or those examples where it's already working, but also those where it's not working and what's missing, what are the next steps. And for this, we have two main deliverables for the package. First, the roadmap, which is a technology review. We look at all these cases which we have already hybrid energy storage, or we could have it to go one step forward in a more efficient system. And then we have also the strategic research and innovation agenda, where here we give the message. Here we're being called, which is society, you have to work on hybridization of energy storage. Roadmap. The roadmap sets the base of how to develop hybrid energy storage, selecting what are the characteristics that we have to look at. And for this, we have divided it in 5 different things. The 3 main ones are from the front of the meter area, and the 2 last one from behind the meter. And this is how we have included them in the roadmap, which, by the way, you should have there if you haven't looked at it yet. You can take it and see that in the context is where we have made this definition of these 2 main areas, and then we have gone deeper in the part of future hybrid applications. And a very brilliant idea that came up in the middle of the process of working on the roadmap, not only to have a stronger outcome, but to engage more those that were providing case studies, was to publish all these case studies and a lot of them from here in a book, a hybrid energy storage book, which you have heard a lot already. And if you haven't, if anyone is joining today and hasn't downloaded yet, scan the code and download it now. I'm not going to go in detail because there has been a lot already mentioning it, and there will be more in the next class and discussions today and tomorrow. But it's a great compilation of the case studies that were mentioned on the roadmap. Going into the strategic research and innovation agenda, here we are providing the message. Here we're providing suggestions. And the SRIA itself, it lists the current and also previous actions taken to address hybridization of energy storage. It has a list of hybrid of Horizon EU and also national funded projects. And it sets the research areas for hybrid energy storage that have not yet been investigated. Within this, we have described importance in 2 or main points. Hybridization is relatively new in the energy system picture. We have to define new strategic research areas that have to be tackled differently. If you think, for example, that batteries have received a lot of funding because they were developing quite fast, but other areas of thermal storage hasn't got the same support. So it's about thinking in a larger level, on a picture, whole picture level. It's to think also about the connection and the synergies with different partnerships and other very relevant international platforms in Europe. And then it's also to get more general support. If our message gets louder, the support on hybrid energy storage is going to be also more effective. These are some examples of the partnerships and projects that have been part and there has been collaborations with Romera, of course, as the main framework, but also Batteries Europe, Waterborne, Clean Aviation, and also Clean Hydrogen Partnership. And this is the main structure of the StoRIES. We have a policy agenda where we tackle first regulations and policy possibilities for hybrid energy storage. And then in the context, we have first state of the art for hybridization, where we include the previous strategic actions on topic. And then on the mission and objectives of the StoRIES, we have the suggested strategic areas. And we got into 5 main points. Long duration energy storage, extending the lifetime of hybrid systems, the system integration of the multi-vector storage expressions, digitalization, and last and most important, regulatory frame. Within all that, the main outcome was to provide suggestions from the legislative challenge, which was also mentioned and connected to the roadmap. So to sum up, this core task was part of Work Package 3. We have 2 main deliverables first. Strategic research innovation agenda and the roadmap. And from the roadmap, we got also an extra very relevant and important deliverable, which was the book to compile all these case studies. It was a fantastic job with most of the people sitting here in this room, but also many others that are also attending online that unfortunately couldn't join today. And also I would like to say a special thanks to Roberto, who can't be here today, for leading the task point 3 and being also one of the main roles that have contributed to it. Thank you very much. Are there any questions? No, I do not. I will give the microphone to you now. Let's go and present task 3.4.
Thank you very much. I will use this one, but I will need pointer.
Yeah.
Thank you. So, hello everyone. Good afternoon. I think it's working. So, my name is Pınar Kaçay. Today, I'm very happy to make a presentation on education and training activities of StoRIES project. And it's not only me, it's a collective input from other partners, Paul from BTU, Linda from University of Perugia, Hussein and Olga from PIT. So first, I will start with the objective of this education and training program activities. For this, I will use this roll-up banner. As you see, one of the main objectives of this StoRIES project is training researchers to ensure long-term sustainability. And beyond the StoRIES project perspective, I would say that education and training are also important. And in order to achieve the EU's green energy transitions by 2050, and because we don't need only the technology itself, we also need to people power as a driving force behind the technology. And we also need a qualified workforce in order to fully achieve this green energy transition. Now I'm going back to the presentation and to talk about the main objective of this program is that empowering next generation of researchers with holistic approach and in the field of energy storage and also hybridization, most importantly, while promoting academia and industry knowledge exchange. For these purposes, there are 7 main programs. I will go about them with giving main key highlights for each program in the next slides. But before going to mention about them, I would like to point out an important topic, criteria, priority that was aimed to include in the entire StoRIES project, specifically also in education and training programs, which is gender equality and inclusion. So in order to promote gender equality and making awareness, two special LinkedIn campaigns were prepared. The first one was on International Day of Women and Girls in Science on the left side. So this is inspired by Power to X technologies in the energy field, and also referring to female chromosomes, XX. So the slogan was created as Power to XX, emphasize woman power in the field of energy sector. And the second one was easy to be inspired by our project's name, StoRIES, with the slogan of StoRIES written by women. It was the acknowledge of women contributions in the project, and of course using the inclusive language to get the attraction of participants beyond the project. And the second campaign was done on International Women's Day. As mentioned, that this gender equality and inclusion aim to include all the StoRIES program, but specifically strong gender equality was achieved in mentoring program, but also summer schools. 7 different programs. The first one was on training program for master students. It's basically provided master students, the target group, with the knowledge of hybrid energy storage skills and knowledge during their thesis period. So last 3 years, different online seminars were organized in total of 14, and the seminar topics were highly diverse, from batteries, ultracapacitors, chemical storage, thermal, mechanical, hybridization, most importantly, grid integration and sustainability. So these are the achieved during the project timeline, but also beyond the project, a master course on hybrid energy storage program designed and drafted, and launch planned after StoRIES project implementation, but of course, after the project completion, but of course, implementation depends on the funding availability. Second program, Early Stage Researcher Network. This is a proactive effort, and it wasn't promised or granted in the original grant agreement, but this was successfully created and further implemented. So here it was, the main objective was that provide next generation of researchers, giving them networking opportunities. And also, most importantly, prioritizing their participations in the entire project. Early stage researcher means basically master students, PhD students, and postdocs within 2 years of their PhD. So currently, the network consists of 46 different early stage researchers across Europe with 34 organizations. So they bring different skills in the energy storage, but also hybridization. And their knowledge and their background also creates kind of hybridization in this early stage researcher network. Third program, mentoring program for PhD students. Basically, it brought together doctoral students and also senior leading experts to support PhD students' research and also professional development. And in this context, 8 mentor-mentee pairs were established and 50% gender balance was achieved. And so StoRIES support them with first the regular online meetings, but also supported financially for their in-person visits. So in this program, 5 different in-person visits were conducted, and the reports of these visits can be also accessible online on the StoRIES website. Summer schools for early stage researchers. So it was intensive program, I would say, alongside the other programs here. So the objective was that training of early stage researchers, supporting research collaboration, but also promoting equality and diversity in STEM. 3 summer schools. Let's look at the numbers. 3 summer schools with more than 100 students participation. So this number achieved the project's one of the KPIs. And the third goal, especially, the planning started just months ago before the actual summer school and continued until the last minute. So this resulted highest number of applications for the entire StoRIES course with 199 applications. It was the largest StoRIES event alongside with the StoRIES project meeting, more than 100 participants in total. 26 different lectures were delivered. Industry participation was also one of the important criteria we always try to consider with 10 participants. Strong gender equality. Across 3 international summer schools, we close to 50%, and the third summer school fulfilled this strong gender equality with 50% women participation, totally gender balance. Inclusion, it's also one of the important criteria. So brief information is that in summer schools for the second and third one, we organized a session for group work case studies. Students come together, they work on a specific group work case studies, and then they made a presentation. Scientific jury voted their performance based on their presentation, and the best working group from second summer school. They were the part of the technology roadmap for hybrid energy storage with a specific case study. And also yesterday, we welcome third summer school's students, best working group, and they made a presentation of their group work, and we invite them to the final event, and today they are also part of our audience today and tomorrow as well. Next program, online courses for workforce. So basically it's offered different courses to equip the workforce from academia and industry with interdisciplinary skills for these complex energy systems. The numbers, 19 different courses were delivered, and topics were highly diverse also. Electrochemistry, thermal storage, hybridization, digital tools, sustainable assessment. And also these courses address EU-wide priorities with energy storage legislation and also low carbon research and innovation, supporting Europe's transition to clean energy. And I'd like to also add one more point regarding this program. Like the other StoRIES program, these courses were offered free of charge by the StoRIES community experts. And so, but at the end, we still reached the highly engagement with 19 different courses. Next, online platform with existing courses on energy storage. It's created a single port online platform for accessible education on energy storage and also hybridization, both on academic and also professional levels course. Currently, this platform is available online on the DTU website. It consists of 6 different energy-related courses, and also all StoRIES program courses, up close to 60, from summer schools, online courses, and seminars are also available on this platform. And finally, you can find other course search tools and links to external platforms. last program, International Research Exchange Program, shortly IREP. So basically fostered collaboration between European labs and also international labs by giving free access to the researchers to use the facilities of these international laboratories. So initially 5 different calls were planned up to month 36 of the project, but then it is decided that the third call can be open until the month of 36. In total, 6 different exchanges were done, 6 different users in total, and they all choose host location as an international location to Canada, and their user reports are also available online. All the activities mentioned here has 3 main deliverables. The last 2 already submitted on the EU portal, and the first one is master program is planned to submit by the end of this month. That's all from my side, and thank you very much.
Are there any questions from that?
Very good.
Thank you very
Thank you
much.
very much. Very clear. Thank you.
I will go for the last 2 tasks from Jan. AIT. So it's yours.
So, looking at time, I can tell you that since Work Packet 3 also in our SureFix updates always was the longest one, we figured that it makes a whole lot of sense to present this task 3.5 together with the working group 2, because basically working group 2 is the implementing body of this. We'll do this later on. So yeah. So then moving on to 3.6, proactive innovation support. It's going to be kind of a summary of what we heard today, because this is a very cross-sectional topic now. And in the proposal, so we said we are going to do the following. We are going to have services on materials with this material platform. We're going to have best practices for cross-level modeling, the online courses, workshops. Okay, when I point online, I need the mouse. Okay, I see. Or is this also?
No,
It's okay, I see. And yeah, something about the raw material use, and last but not least, the selection rules for the research infrastructures. This is what we had as a service portfolio, what we promised in the project. And I think let's just together have a look what did we do concerning all of these points, right? And a lot of that we see now is something that you might have just heard right now or in other talks. So basically, speaking about the material acceleration platform, this is what Kuros just presented an hour ago, maybe less. Yeah, so we developed this kind of digital ecosystem, this metadata infrastructure framework, also with a large language model enabled this graph database, this Neo4. I think you dug into that, right? And yeah, and the main thing is it is built on ontologies from this European material modeling ontology, this one. So yeah, working together with something that is established on a European level. It is well, this Vimilabs platform that is there at Jülich is something that went into there, and it integrates this graph database, this semantic search that really proved to be very valuable. I think that it's possible to use the semantic search, and services like automated data extraction and this customized knowledge graphs and something like this proved very valuable. Correct me if I say anything wrong there. Perfect. Okay. And then, so following up on what Kai just presented, we had this modeling framework where one of the key finding actually was that we need those reference use cases, because otherwise it's just a framework without, I'm not saying without a soul, but it's people are not wouldn't really know what to do with this if you don't have the use cases. And the two use cases were this renewable energy community in Spain, where foremost combining this electrical and thermal storage, and on the other hand, this service stacking with the hybrid storage in Denmark, where so one of the main novelties there is, I think there are lots of frameworks out there, but something that's so really not so common or even not yet implemented is that you have something that can do this service stacking, because you can do with other platforms, you can do either one service or another one, but you cannot really have a look, okay, if I do this service, but also want to do this service, maybe at 40% of the time, how are they cannibalizing each other? So this is something that we did there. Important to know is both are open source. They are available on GitHub and Zenodo, and the pipelines are text-based, which is helping a lot for automated simulation. And yeah, and the second use case there is actually linked to the material acceleration platform that we just saw. So I seems to be happy, so thank you. So I also brought you a screenshot that I think I just to see that also there is.
He had it very small.
He had it very small, yeah. So just to see that this actually, it also looks nice, because we have to sell our stuff. So actually, this thing looks nice.
You show a little bit what we see here, just to.
This is something that you would have to ask Kai, I think, because yeah, this is.
No, it's just.
I can do it because
I can do it.
Just with the
Kai is here.
deciding what is there.
Yeah, but okay, but yeah, good question actually. But then, but before I say something, because Kai is the expert here.
Hello, yeah, sorry. It's just an impression, right?
Yeah.
But what you see on the right-hand side is basically the outputs of the time series that are calculated. And then on the left-hand side, you see KPIs in 3 different areas. So there's losses, degradation, and the benefits in terms of, it's not costs, it's
You are on the left, yeah, but you're comparing 3 different.
There's just 3 different, let's say that those are 3 different KPIs that are studied for the scenarios that are being investigated. And here on the right-hand side, we see, if you go back for day 1, so one of the time series that was input was the outcome of the simulation.
You're basically,
you're
you're basically comparing 3 different storage technologies here, right? So
yeah, they're combined.
they're combined,
That's the
yeah.
thing when you have a higher storage, okay.
Yeah.
A bit more. You do have the different power profiles of these different storage technologies, so they're contributing to providing a frequency service. But you see that maybe it's in the bottom easiest to follow because it's slow. The supercapacitor is changing its state of charge very rapidly, providing high power, high frequency input. And on the other end, the vanadium battery is responding more slowly and kind of giving the slow moving energy contribution to the initial signal. And together they're providing a frequency service, which is where to get the revenue. So you have to provide the capacity, you get the money for providing the capacity. And with this, you can evaluate if the degradation, for example, of the lithium battery is worth the revenue you're making. That's the kind of trade-offs you can study with this.
I can also give you an interpretation what I see, then you can see if I see it correctly, but I see a supercapacitor that is doing lots of work. That's always basically going back and forth. Then there's the lithium battery that's much slower, and then the vanadium battery that is even slower.
But yeah, the optimization that's behind this respects the constraints and the costs of the different weight parameters. The losses, it includes the degradation to decide which source is being used. Dedicated, and then we have a controller that in real time dispatches the units by filtering the input signal. But all that's why we need to combine technology and the controls to understand what will be the operating point. So if you're a technology provider, maybe you'd like to take the time series out because you want to run that in your lab. But if you're assessing the technology, maybe you're only interested in the KPIs.
And just it's very hard to read. So the time series, what time series?
24 hours.
24 hours.
So this is actually for a battery expert. This is perfect. The redox flow is working over 1 day. The lithium-ion battery is working over 1 hour, and the supercapacitor is taking everything below. I mean, it's a perfect example of integration.
Thank you.
Then I think I will be moving on, right? So looking at the
back to
time.
the discussion. I mean, it's good to bring it to the ground. Yeah.
Perfect. So, okay, I was thinking, should I include this? But yeah, I was right to include this. So,
Very good.
okay. So then fair and open data. Always a topic, of course. To maybe sum it up, it is, of course, the whole energy storage process is closely tied to fair and open data practices. We tried also so it's now interlinked to 1.4, I think. 1.4 is the actual task for what is fair data. So we are not only looking at work package 3 here. The FAIR principles, there were these ontologies. There were also a lot of workshops in this 1.4 thing working on that. Then also this knowledge transformation that we had for the graph database and the large language models that would put in there. And then I think we can claim that with this fair data speeds up scientific breakthroughs and scaling of new energy solutions. There is a deliverable targeting this also deliverable 1.5, and also in the economic dimension with basically what we have here is reproducible. We have no new business models as we just seen here. This is basically something showing new business models here in this platform, and digital twins, something like this. And then also embedding fair practices in industrial technologies, something like this. There is also a deliverable targeting this deliverable 1.6. So. And now moving on to what we really just heard, actually the StoRIES education and training program. So just quickly going through this, also having a look at the time. So as Pina just said, there was this master thesis, mentorship, the early stage researcher network program with 46 researchers, the PhD mentoring program, the summer schools, the online courses, and the online platform. Like this, and there was a workshop series. So I took a picture from the workshop in Vienna, actually, that I had the pleasure to organize, where we brought together the researchers, industry, and policymakers in this workshop series, trying to focus on sustainability, decision making, integration of energy storage, and for example. So the methods used, there was this multivariate decision analysis, or also the business sustainability canvas that I also co-developed a little bit. This is, again, now we have work package 4, actually. It is task 4.2. So we are really all over the place in this task. And the workshop served as test beds for decision-making tools and, for example, also testing if this business canvas model is something that can be used or not. This was something that we did in Vienna, for example. Important to say is that the industry partners actively contributed there. So we had lots of industry partners involved, and the outcomes, as Pinar said, so also went into regulatory recommendations, identification of areas, this roadmap. Yeah. This is the workshop series. And last but not least, on this part, also the proposal selection process was something that we promised in this service portfolio. Yeah, coming to what Olga said before. Of course, every proposal that was evaluated to peer review, and of course for scientific excellence, for the alignment with the StoRIES and the new priorities, and also, well, because something that we had a look, raw material efficiency and social impact was of course something that was valued in there. And yeah, project addressing, also substitution of scarce resources, recycling, something like this were favored. Also life cycle assessment was a key topic there, and sustainability evaluations, and the, of course, main thing, innovation potential and hybridization. Yeah. Okay, and then maybe the main thing for me in this task of this task 3.6 was a kind of front desk service that we tried to implement to maximize the application, to maximize the outcome of the application in something like this. And therefore, it was first of all to have direct support for all the users applying and to enhance the success of the proposals by proper outreach and informing the research community about the new calls and how they can apply and this stuff, and the dissemination activities of the project. And I think the success can be shown because I think in the first one, I hope I got this correctly, otherwise Olga has to correct me. But in the first call, we only had 4 applications because Olga said we were just not known in the community. Nobody knew, and the people who knew said, "What does this hybridization mean?" And therefore, nobody really they were a bit reluctant to apply. And then we reached a peak value of 14 in the 4th call, but it was always 2-digit numbers in the last calls. So what did we do? There was, for example, this slide that we asked people everywhere where they went to, that has to do something a little bit with StoRIES. Include this slide just at the very end of your presentation and advertise the project, tell the people that they can apply there. So this was one of the slides, of course, for each call. And if one scanned this QR code at the right-hand side, you would directly come to the application section of the StoRIES Hub. Then there was, of course, this feedback formula. How do you say questionnaire that the people using the transnational access, the researchers should fill in order to get a feedback, in order to see how we could improve. And this actually goes to working group 3, which then had again feedback for the working group 2, which we hear later on. And there also was a very simple, but I think maybe one of the most efficient method was also just to contact people, just contact the people that you know, because those were those that were most likely to apply maybe. Therefore, we prepared a standard mail just with the call topic, with the link, tell them what is the next call about, just so that our community could just forward this to the guys who wanted to apply. And I think at least the rising numbers of applications showed that this was successful. Okay, so now taking a steep curve to conclusions, because So these are now conclusions that you cannot really draw from all that you've seen here now. But it's kind of conclusions that we drew anyway from the whole project and also in the respective deliverables. Basically, we gave it some thought. What kind of conclusions would we like to tell you here from all of this? And we came up with the following. So first of all, the market for energy storage is a difficult one. The fossil cells are still too cheap, therefore it makes it difficult. But on the other hand, for really a clean energy transition, large storage are paramount, and hybrid makes them cost efficient. So this is, yeah. On the other hand, as we know, the battery production is taking place maybe not in the European Union, but in China. I don't know, Stefano maybe has some thoughts about that. But it would be good to motivate the industry. It would really be motivated to invest in the storage, because otherwise the clean energy transition is just not possible, actually. And on different vectors, right? If we want to reduce the CO2, we want to be resilient again, now getting back to battery production not in the EU, and yeah, reduce this dependency, right? And therefore, we need it as a reliable energy source, actually, because otherwise we will be falling behind, actually, behind other actors. And yeah, therefore we have those follow-up projects, Rise Energy and AI StoRIES, also where Rise Energy focus more on couple the hybrid storage with generation sources, and the AI StoRIES more towards digital twins. And there is a proactive innovation support strategy also in these projects. So for Rise Energy, it offers the possibility to improve the access proposal before actually really doing the access. And for the AI storage for the AI StoRIES, it's an early integration of stakeholders in the development of digital twins. And I think that's all for the work package 3.
And the final count maybe
Yeah.
the session.
Yeah, well, first of all, any question for Yannick?
Yes, sure.
Everybody wants to go for lunch, I'm sorry.
Yeah.
But you made a wonderful presentation, and I will steal your conclusive remarks.
Yes.
I like that very much.
So Olga has a lot of influence on the conclusions.
I know.
So I cannot
Okay.
take full credit for that.
Good, thank you, Olga. Okay, so the morning session is over. We go for lunch. I want to give an important information. Tomorrow we can start sharp at 9 o'clock tomorrow morning. So just to favor people that, like me, for example, has to catch a flight back to wherever you go. Okay, so 9 o'clock we can enter and we will start with the first panel right after.
But please not earlier than 9.
But don't come earlier than 9. Somebody this morning showed up at 8 o'clock and he was admitted, but they don't really like it. Okay, 9 o'clock, please come up, and we go for the panel. So now enjoy lunch.
That's great.
Almost done.
I don't know who wants to start.
This is also going to be my conclusion.
Oh. The consideration of it from the there. And then in June, we decided to go for this. It's another one, this artificial intelligence.
Different storage, but do you have that like data from?
No, so that's a more screening tool, more focused on the device and material. So it's more database algorithm. So some of that database is Excel database for energy storage. Some of them others we corrected its accounts. But so it's not really like a simulation of the place of things, or they can database of the applications, you have database of and then it has scoring factors. That each is scoring factor. Let's say if you have different factors, 10 different applications, there are scoring factors calculated based on the range of energy density. So it's a screening tool is nothing that you can use as a decision making. This is my tool. It's the mystery of the battery type. It gives you a range of applications.
Yeah. But what I'm wondering is like, is the data from actual experiments? Because
it has gone into but not the experiment that we did from this stories. As I said, Intel and others, in advanced space time for collected a lot of things of experiences. Like little school battery databases from chemicals, from different sources.
Because I'm working mainly with batteries.
Yes.
Like I just like the source there efficient.
I can show you the range of the batteries databases, which are just attributes. And beyond that, it's from different sources.
Additionally, there's a lot of citations from massive scale systems.
Some of this data we also did through interviews, long interviews with experts.
Okay.
So it's not just that. It's not just that. But we can send you the technologies.
Is it just accessible online?
I think it is. I think it's also in the sharing system. Okay. If you have access to what package to read.
No, I was just I am at KIT, so maybe I get it.
I can send it to you if you can talk to that.
Yeah, I think I talked about. Really interested.
But as I said, these are not system simulated. These are screening demos. It's different than like if you have if for screening technologies, not for screening configurations.
Yeah, but even for staff technologies, like I'd be interested in seeing that. There should be a lot of times that very slow batteries inside have efficiencies between 70 and 80%. One time I almost felt I almost got this like the research.
So if you look at the way these things, the output of these things are always output in a range because once or so, it's like that has been the biggest problem. Problem is that you have a lot of technologies and nobody knows what is the best that is the same problem to solve. Use a range and say this is for batteries, this configuration scenario is the best range.
Okay, can you hear me?
That was
The overlap. Yeah, but for us, component data into the
Yeah,
you can do detail. Device but then the uncertainty. So instead of putting complexity of the device.
Provide to stay so
Yeah, that's like, you know.
These scales are very.
also work back data plan.
Thank you.
Yes.
Watch meeting.
Very.
Can you hear me now?
Same.
Yeah. I think it's because the presidency is changing every six. We also targeted the one in alongside the the end of the year.
We will be. We are not staying for the.
Weil wahrscheinlich, weil wir schon zu etabliert sind, um für diese relativ neue Struktur zu sein. Das ist ein bisschen die Frage.
And
Wie kommt man denn dahin?
No, already, yeah,
Stunde war ja.
Sorry?
so it's working.
Ist ja das Epicenter.
Norwegen hat einfach so wie, ne, das machen wir jetzt so schlecht.
I think yesterday there was another colleague on the yes, performance participated in the high level discussion. On tomorrow in Nature, I think it's confirmed.
Maybe I
think it's okay. Something important.
Is it okay?
Yes, we can hear you. I just want to see if we can hear you. Right.
Okay, because I cannot hear you because very many noises.
Can you hear me now?
No, because it's very noisy around because so I can hear just people speaking, but.
1 second, I'm going to check the microphone.
That's for you not to come.
Deutschland ist es jetzt 2.
We can also check languages as well.
Für Darmstadt. Das BGS. Yes, thank you. In case I come, I will darüber halt.
Thanks, sir.
Yeah.
46 jetzt.
Very, very nice work. You know that we have another project called NDP.
Yes.
Just the white paper, yeah.
We are working very closely.
Yeah, I know.
Das ist diese nationale Verantwortung. So ein Netzwerk, ein Gegensprich, nein. Wenn du dann sagst, okay, jetzt machen wir aber SV, dann ja, dann raus.
Yes.
Das ist ja genau das, was du
Yes, they were collaborating also in the chapters of the book. Collaboration, there are some professional things.
Research counts.
Yeah, because they are not fully, but officially. Very good. And there was for one.
Klar, so sind wir halt gar nicht, wir sind eigentlich alle Laborleute. Ne?
Jetzt noch ohne.
Yes.
Very good introduction from the Twitter election season.
Yes. I will we'll talk with you when you're doing the review.
Okay.
Also because Rice Energy reviewer has done also the review everything. Bring in the season.
What's what it was like? Yeah, that's what. Yeah. Yeah. Yeah, I think we mentioned that.
Yeah, could be.
Yeah.
It was my.
overview of everything that's in the just something. Oh, I see. And what we are trying now in the long term, was comment a little bit today, is this office. StoRIES office, so we want to talk to the directors of the to combine some to go in that direction of the community stream and infrastructure. This is also a lot of involvement from member state, more than from the commission. But this is our long-term view. So, candidate, yeah, there is a bit more. It's forgetting but not. Maybe we can also discuss this with you. Yes, and no. Yes.
Slowly, right. It work. And having that's what I spent having one of the phone, having architects. So that's the success. Yes, great. Are you someone important? Yeah, our colleagues are really one of them. Okay. Are you coming for lunch?
No, I'm also making. It was suggested short.
Okay. Yeah. But thank you for coming. Very good. Just
I really do just. Yeah. Yeah.
finally.
This is very good. It was kind of football there. There's something you want for some right? Oh, we didn't. Yes, okay. Yeah, please. Yeah.
Ah no, però non è esatto. La batteria, non so capire, quindi c'è la regola. Perché non mi può fare solo le regole. Non posso imparare meglio. Io dalla posso rinunciare a tutto. Ma fare una cosa, stare ora 2 giorni a raccogliere disorganizzati completamente. No, questo faccio. Io andrei per la sera. Sto più tempo per strada, sto più tempo per strada. Gli anime possono aspettare. No, ricordo che a casa, ci lo vedo solo. Ah, io come faccio? Io mi fate di Valentino, c'è tutto, c'è il pezzo di io fra 10 minuti devo fare. Poi eviterei di affastellare e sommare, possiamo
That's a great. Yeah, they're downstairs.
I saw her in the bike. I think she's not joining this.
No.
A me?
Sì. Pronto?
Ho chiesto ai miei di inviare i prossimi lavori che abbiamo urgenti da pubblicare su Open Access, PNR, eccetera, di inviarli, provare a inviarli fatte invece che su.
No, è impossibile.
Cioè, cosa impossibile?
È impossibile pubblicarli adesso.
No, inviarli, non pubblicarli subito.
Non te li accettano proprio.
Non ti accettano, allora è aperto, ho visto.
È aperto, però fondamentalmente è aperto su inviti, perché all'inizio...
Ma c'è scritto questo?
Sì, provateci.
Se no non l'avrei fatto. Ho preso la pagina ufficiale, cioè now open da settembre 25.
Sì.
No, figurati, io non è che era un'opportunità, perché no, in genere come strategia cambiare MDP la cosa poteva essere, visto le tue parole, avevo colto, poteva essere interessante, ma come strategia a lungo periodo è da provare, è provare questa cosa.
Ma praticamente
È solo per
il target di Rose è andare a Impact Factor 30 in 2 anni.
E l'ho capito questo.
Capito? Perché significa che fondamentalmente inviteremo lavori di pezzi da 90.
Immaginavo.
Io non posso pubblicare, per esempio, perché sono editor, quindi sono escluso automaticamente.
Immaginavo, non volevo inviare.
Provateci, che ne sai?
Comunque, alla fine sono voluto.
Ma non ve la prendete, però.
Chi è che se la prende? Io quando mi boccio, vabbè, anche su Journal Power Source è difficile. In questo caso sarà più complicato perché c'è questo target che mi hai detto tu, ma non si offende nessuno. E poi non è che. Perché anche quando inviamo in MDPI non è che inviamo con lo spirito, che tanto è facile. Perché quando scriviamo gli articoli. Sull'open access sull'open access che noi serviamo in questo momento per problemi di blocco del budget che è un schifo. Abbiamo cambiato il sotto PNRR sistema di accounting, il bilancio interno. Dai 2 anni che non ci rilasciano, ci danno i soldi nostri per poterli spendere. Non facciamo. Non facciamo. Solo il nostro dipartimento di ingegneria e trasporti ha 13 milioni di euro non spesi di progetti running perché non li ha girati, non li ha fatti spendere. Io StoRIES mi ha
mi è tenuto a galla.
Ha salvato la vita.
Per venire qua perché avevo 4 residui sono dovuto venire qua, ma se no non si può fare.
No, penso io non so come fare. Io sono
No,
sono scappato da Roma.
Comunque hanno ucciso niente.
Mi sono reso conto come funzionano le cose, dico no, è inutile che io sto qui, perdo solamente tempo. E allora me ne sto a casa. Difatti avevo deciso di starmene a casa, poi dopo mi hanno offerto questa posizione in IT. Non è possibile, io non so come ragiono.
Era il direttore generale che ha creato questo mostro, allora l'hanno premiato.
Come si chiama? Lo conosco.
Molpani.
Sì. Ah, sembrava pure una persona sveglia, pensa tu. Lo sai che stavo nella commissione del CNL che ha investigato sull'incidente che c'è stato a Napoli?
Dell'auto? Vabbè, diciamo messo nelle condizioni di dover lavorare sempre. Cioè, in senso di preciso, non ti chiedo questa cosa specifica. Ma lavoriamo sempre in emergenza. Direi che dopo quell'evento, rispettando tutte le regole, i nostri tempi si sono triplicati perché non c'è la struttura. Il ricercatore è solo. Non c'è tutta la struttura che ti supporta.
È tutto così.
Quindi lì hanno rischiato troppo.
Guarda, all'università hanno rischiato molto. All'Università di Roma l'unica cosa che hanno fatto, diciamo che mi hanno supportato, è stato il caricare tutte le mie pubblicazioni sul sistema perché così ovviamente non mi hanno detto no, puoi caricare. Io ho iniziato a guardare e ho detto siete fuori di testa che io mi metto a fare quel lavoro, cioè a caricare 500-600 pubblicazioni una per una. Dico se lo fate voi va bene, a me non mi frega niente.
Poi hanno trovato il modo di fregarci. È vero che poi sono andati normali, siamo a regime, però nei concorsi interni ci valutano soltanto quello che è là e quindi ti obbligano a prendere dopo la quella la BQR sostanzialmente.
Sì, è ricco.
Lo passa da là.
Anche a quella avevo partecipato alla precedente valutazione che c'è stata adesso.
Sì, sì,
praticamente io come al solito prendo un impegno, lo faccio e l'ho fatto nei tempi prestabiliti. Quando io ho finito, quell'altro devo ancora cominciare ed è arrivato il messaggio che le valutazioni devono essere tutte. Allora, prima di tutto all'inizio avevano detto le review non vengono considerate importanti. Io mi sono guardato e dico, se non dite praticamente dopo che io avevo finito mi hanno detto che tutto era cambiato e che bisognava fare valutazioni più elevate. Ti dico, guarda, voi non mi avete dato nessuna indicazione, io utilizzavo un metodo di giudizio, ho preso che so, me come riferimento.
Hai chiuso 3 quarti delle.
Poi ho tagliato il 50% e ho detto vabbè, chi c'è il 50% del mio riferimento perché in Germania stai in un posto meraviglioso, no? Prende il massimo punteggio. Però insomma mi sa che non ho dato a molte persone, cioè quindi ho detto ma così tutta la chimica viene tagliata poi, ho detto vabbè allora io esco. Cioè non ricomincio da capo, me lo di prima queste cose, datemi un chiaro indizio, no? Non mi puoi dire che sei libero di fare quello che vuoi e poi dopo mi dici che tu hai sbagliato tutto. Dimmi quello che devo fare.
Parlando di ritardi e cose ministeriali, mi sono accorto che ieri mi sono ricordato che il Ministero mi deve pagare una revisione di progetto da. Allora, se mi chiedi soldi, quanto ha maturato nel frattempo? Io gli faccio però li denuncio.
Sì.
Per loro in ritardo.
Sono dispiaciuto moltissimo di questa cosa, però è impossibile.
Ma va sempre peggio. Vanno in pensione le persone, non sono state sostituite, c'è un gap generazionale che non è stato coperto.
Sì, ma a Roma, per esempio, quando io stavo lì, scusa, quella è stata una cosa del motivo per preso. Poi io non ce l'ho con nessuno e capisco tutto, però a un certo punto hanno fatto, come si chiama?
RTDA,
RTD,
là c'è la RD.
una l'hanno fatta RTDB che significa che gli anni diventano associati, quello non è mai uscita dalla persona. Cioè, è sempre stato nello stesso gruppo dal bachelor, di master, PhD, postdoc. Non è possibile, le persone devi cacciare. Actually, if you want to find
This is very expensive.
Vabbè.
She found the mobile phone downstairs. Yes. Maybe you can tell people that
we found a cell phone.
downstairs.
Yeah.
We found a cell phone. Does everybody has his own cell phone?
Yes, in people.
Otherwise, I can give it back for €100.
Over there.
It's you? Okay. To you for nothing.
Still people from the picture. I wanted to be before we go for lunch. Should we do it right now or should we do before the coffee break? Because there are still
Because he will
people
leave.
coming.
He will leave.
Okay,
Let's do
then,
it now.
okay, then,
But how do we do it?
I don't know.
Yes.
Everybody here. Everybody come here.
Picture?
Probably do this. I don't know.
Everybody come here, please, for the picture.
Happy everybody.
Downstairs. in
Tall
front.
people on the back.
Let's have a StoRIES logo there.
Yeah, we need to get stories.
But I think so.
With the boss.
Yeah. No,
No, we have stories here.
yeah, they're going, are we sitting here or should we go downstairs? In the hall?
Ground floor, there's empty area. In ground floor, there was empty, large empty area.
At the end of the year.
Yes, yes. I don't know, many people can fit here.
But it will take like 20 minutes to downstairs.
Yeah.
So just-
Okay.
Should we try it here?
Yeah.
I think we can try it first.
With the Photoshop, I will put myself.
Please come here. No, don't pull it out. I want stories. The tall people will cover stories, so we might. Come here, tall. Anybody with below stories can see. You are told for myself. Come on.
Oh, I'll go. I'm so big.
You have both.
Roll.
Oh, that is to be discussed. I do that. That's
Some share. And some people in the front making the.
one more row here.
Margarita?
Don't worry. He was the
Someone is in the front?
Olga, on the back.
Yeah. No. We all here? No, Miriam is here.
Where is Miriam?
Yes.
No light.
There is a.
Miriam. Boss.
The electrical engineer. Degree.
You started the stories, yes. That was cool. Okay, now the boss is not here. Done? No?
No.
Oh, look at the platform. But even the word, the fellow will blind.
How about it's hybrid?
This great performance. It's time to get ready. Something wrong with
Ah, okay, okay. So the slide is not touched.
I want to take a picture of that.
Yeah, that's, yeah, nice cappuccino.
Thanks for your time.
Yeah, it's just all the. I cannot believe these people actually sitting in the last, but maybe the reason are the two monitors, right?
Yeah.
It's easier to look at the monitor than the rest. Okay. This is funny. I will not put online this. Ready? Almost? Good. Okay. My mic is not working. Switch it off. Then on again.
Yes.
It's not working. I use the other one.
Yeah. Yeah, you keep it.
This is working. Okay, so consider, guys, that this is the last section of the StoRIES project meeting. Okay. And we started the last session with work package 4, which was definitely one of the, let's say, 3 or actually 4 work packages in the project. And the presentation will be given by Marco.
Yes.
Ready?
I confirm. I'm ready, but I don't know the presentation.
Next slide.
It's right? Okay, great. All right. It's true. Okay. Thanks. Okay, welcome back. Now I'm going to recap what happened in 4 years in work package 4. In a short way, I guess. I hope. We I have to leave. And despite the very challenging title okay, that supported the transition toward the climate neutral continent, the work package 4 dealt with the sustainability assessment of the technology of the hybrid energy storage technologies studied and assessed in which will the project was focused on. The main goal of this workshop, the work packages, was the need to improve the understanding of the optimal storage portfolio. What does it mean? What does it mean that when we choose one technology or an hybrid energy storage solution, we generally will take care about only about KPI, technical KPIs or economical KPIs. The challenge was also to include other layers of the sustainability, including environmental aspects and social aspects as well. So trying to have an holistic approach, also a methodology that didn't exist before. Also, so you need to improve the understanding of operating environment, also to accelerate the deployment of hybrid energy storage. We collaborated a lot with the work package 1, work package 3, also sometimes also with the work package 2, is to find the words and the topics for the calls. And as you already seen, but we are going to show you how we contributed also for the SRIA, for the roadmap as well, and giving to these documents the point of view of the sustainability. The last is how to harmonize the different methodology and tools. We spent almost 1 year to collect all the tools, all the KPIs, discussing a lot, enlarging the ecosystem, because this project starts within the energy storage, in particular the SP6, that are focused on the sustainability assessment of energy storage in general. And we translated this experience in the StoRIES project. So we take also the occasion to enlarge this network to strengthen the network itself, and also to, I will show you the last slide, how to go beyond the project, also in the leverage energy storage, take the chance of what we done in the work package. Here is the rough path of the partners of the work package. Apart CNR that I represent, KIT and Iraq, there was the main important partner in terms that they take care about the two tasks. I would like to take the chance today also to say thank you to Sweden from Iraq, and in particular from Manu from KIT. Let's say KIT was the backbone of the work package before. So they was very involved with a big team. So the goal reached. I would like also to thank them again. So the structure was very simple. 3 tasks with the 3 deliverables. So the first one, deliverable, was focused on the creation of guidelines in order to collect primary data for the sustainability assessment. We generated a map of the tools and the questionnaires to be used to collect primary data. We started. This was the first step, and so the second deliverable was focused on the provision of a common base for the economical, techno-economical, and socio-economic assessment. Is the core of the final document that is the white paper that has been presented yesterday. So the deliverable 4.2 is very comprehensive, very large document, technical document. So starting from this assessment, we provided also the final white paper that easy to read and with the final recommendation as well. So this the work we have done. The distribution along time is quite stable during the time. So with the 3 different deliverables, the last one is expected at the end of October. Is in the reshaping form to be readable. To increase the readability of the document, and we have had also three workshops. These 3 workshops were very important for us in order to increase, enlarge, and establish the ecosystem regarding sustainability assessment of hybrid energy storage. Also open the StoRIES project to other projects, European running projects, or other competences outside. So what we achieved finally? We established the sustainability network of competence. We enlarged it, and a lot of people contributed to the white paper, to the public final publication. Okay, so now we are increased also people working and aware about the hybridization of that. So also taking into account the 3 layers of the system. The 4.2, as I already told you. We established also the sustainability energy workshops series that can be also go beyond the StoRIES. So it could be appointment also to take into account what's happening about the sustainability assessment of the hybrid energy storage. The workflow. So as I already mentioned, the workshop were very integrated with the development of the deliverables and the documentation. So this was done in order to receive feedback from outside, from for other work packages and so on. So starting discussing with the 4 working groups of the StoRIES project as well. So the first workshop was mainly focused on the data collection and the fairness of the data collection in terms of metadata that is much being produced and generated. And I guess that is output also in the other data provided in for package 1. The second workshop was focused on the assessment of the methodology, discussing how to perform the integrative assessment of the 3 different layers how to represent it, and how to assess the an holistic tool that I will show you later on. The final workshop was the wrap-up and a use case for the white paper. Okay, we used the time spent in the workshop in order to perform the workshop that is needed for the integrative assessment of the sustainability assessment that yesterday Manuel already presented in detail. So already mentioned that work package 4 has had a lot of connection with the other work packages and working groups. Also, given our point of view, our contribution about for the StoRIES, for the roadmap, a joint workshop that we participated, organized more workshops than the one foreseen the plan, specific thematic workshops, and scientific publication and the books. So I reshaped a bit the last presentation I've done. I focused this final presentation specifically on the workshop, leaving the tasks at this moment, because I would like to highlight how the people outside and inside the project contributed to the content of the white paper on delivery of 4.2. So the first one was an online workshop in order to speed up the process. And we received the presentations and the participation from different experts across Europe and US. As you can see on the left, maybe you cannot, but I can mention it. And so we've invited also component members of JRC, University of Alcalá, Organ National Laboratories, in order to assess which are the different database of primary data, which are the different tools used also worldwide. Okay. So inspiring us in order to find the right direction to the work to be performed. So with a distribution along the west part of our planet, so US and Europe mainly. We can see that the feedback was about the challenges are the reporting in the left, the availability of data, of reliable data, right, and comparable data. This still after 4 years, not for our fault, still remain the main challenge. Till now, there is the chance to have reliable data due to IPR mainly, but not only. So I hope that the StoRIES project and work package 4 is just the first step. There is a lot of interest, a lot of job work to do, so we can imagine a new project specifically addressing to generate primary data for energy storage in general. I take the chance also to discuss with you that we have had the opportunity to discuss with EcoInvent in the last days. So EcoInvent is the biggest database for the sustainability assessment worldwide. And we are going to sign an MOU in order to make the data we collected within the StoRIES project also feasible for the EcoInvent database, and to pave the way for the future data collection. So this is the first step, and this is already done also within the ERA GP energy storage activity. So we will do also later on. The quality of data, interoperability, IPR, engagement of data providers are the main challenges that we registered. But during the second workshop, we invited people also outside the project to participate and give us confirm the base of our deliverable 4.2, the document, in order to not avoid to mention something or to be comprehensive, to collect all the information and to find a way together to use which integrative tool to be used for the final assessment. So it's been decided to use the CDA tool ELDA from Helmholtz from KTE. So we decided together how to proceed in the document, in the drafting process and the assessment process of the identity storage. So this is the concept. Obviously, already we know that the hybridization is needed when just one single technology is not able to provide the services of the final use that is developed for. And on the bottom, you can see the list, the graph reporting the list of the different tools and the need for the harmonization. The integrative tools, we decided to use the MCDA we already mentioned. So during the second workshop that began in Vienna, we consolidated the development approach for the sustainability assessment, the criterion of selection, the decision support tools, and the selection of the KPIs. We started this very long discussion about the KPIs, technical, economic, social, and environmental, that the output of these workshops was integrated also, were integrated also with the work package 3 discussion about the KPIs. We have had with the work package 3 also a long discussion about the use cases. In order to avoid to waste time and efforts, we tried to have the same common approach regarding the use cases. So the last workshop, the main goal was to build to consolidate the KPIs, the list, to find, to close, to the blueprint of the methodological approach and the best practice approach. So in order to speed up the process of the assessment of the methodological tool using with at least one use case. We tried to have more use cases, but it was very, very difficult to have suitable data in order to perform the assessment. So the use of the final output was to drive the writing process of the final white paper as well. We decided also, we finalized how to show the results in the business campus template. We adjusted it, naming it sustainability business campus template, adding the layer of the sustainability. So we used also this approach to select the KPIs that has been used for the final assessment. So finally, the white paper, we decided also to use to organize the white paper as a complementary document to the SUIA and volume. So the three documents must be read together. So coming back to the chronological event of the work package 4 very quickly, we finally generated the guidelines for the generation of data, primary data. Moreover, public webinars carried out jointly to several projects. One was the IBIS project. The other one was a twin vector, specifically addressed on LCA of energy storage solutions. We organized also webinar exploring the social dimension of sustainability, mainly led by KT, sorry, within the twin vector project. We provided also finally a database of primary data collected, data coming from literature or from running projects. For instance, a national project in Italy, like the system specifically addressed on development of new materials for batteries. And I built this project as well. So we collected this database and will be available soon. I hope as soon as I solve some problems regarding the availability online. The task 4.2, the output was the deliverable 4.2. So the core was the definition of the sustainability assessment approach methodologies. That the important thing that I would like to address here is that was a huge work done by several people. So we organize the work also to the experience of the TTP, the StoRIES. So collecting different documents with the 4 different topics of the documents. So the 3 different layers: environmental, social, and economic aspects, and the integrative method. So we collected all the contributions of the people, and we digested them in the final document. So it's very comprehensive job. So which is the target? Simply.
Was this the paper just published a couple of weeks ago?
Yeah, I will mention.
Okay.
I will mention. The target group of the deliverable 4.2, this is a little bit different of the white paper, academia, policy making and regulation, but if people is already trained about LCA and LCC and so on. Industry and incipient practitioners is also a guide for new, not for the training people, for instance. Another important trick is that we tried in this deliverable, in this report, also to include some preliminary assessment of, in terms of sustainability assessment of hybrid energy storage solutions, with information coming from the project I already mentioned. There is a use case, specific use case in the document coming from the hybrid project. The hybrid project was focused on the realization of an hybrid solution combining lithium-ion batteries and heat pump with heat storage for domestic application. This use case is included in the book. So we tried to use the information also to cope other gaps in technical terms of technical aspects. It's very important, this experience as well. Finally, this work finally, thanks to Usain and Manuel, arrived to the final destination that was published in the Sustainability Energy Fuels. Is a synthetic, obviously, form of the deliverable 4.2. Is a revised version, updated, but it was a very important, final result of this stuff. Also certifying the contribution of several people, the engagement of several people. Other output of the work package 4 in terms of publication were the 3 already